Good evening, everyone, and welcome back to day 2 of our GIS workshop. I hope you are all ready to dive back into our exploration of geographic information systems. I am Ayushi Shah, and I will be your host for today's session. Before we begin, I'd like to offer a gentle reminder. If yesterday's session intrigued you and you find today's session insightful, consider joining our upcoming GIS workshop. This workshop, which will also be taken by Mr. S. Bala Subramaniyam himself, will not only cover the basics but will also provide you with in depth knowledge about what you learned yesterday and what you'll continue to learn today. As I hand over the session to our speaker, I kindly request all participants to keep themselves muted. Queries can be typed in the chat box. We will be conducting a live Q&A session at the end of the workshop where you can address your questions directly. Now over to you, sir.
Thank you so much. Did anyone of you have any doubts or queries from yesterday's class? Anyone want to ask something or can we continue? Okay, so today I won't be covering any theory. We can directly jump into Google Earth Engine. Okay, 1 second, let me share my screen with you. My screen is visible, right, everyone?
Yes, sir.
Okay, so yesterday I just started with JavaScript. I just introduced you to what variable is, right? So any queries in that? Can anyone just put it in the chat box what variable is quickly? Just to know whether you guys understood or not. I assume everything is clear till what I've taught yesterday. Okay. So now I'm here declaring a variable. If you guys want me to zoom into the screen, just let me know, guys. I'll do that. So after end of every statement, I'll put a semicolon. Okay. I'll just zoom this in a bit. Okay. So yesterday I created two variables and I did a sum of it, right? So similarly, you can do any mathematical operations with the variables. This is of type integer. Okay, this is a whole number, so this is of type integer. Now next, I'll create one more variable. So variable, whatever name you are comfortable with, you can give it, but at the end you should be able to identify it by the name. Okay. So this is my another variable. Here, this is a sentence, right? So when it's a sentence or a character or alphabet, I'll put it in a quotes, single quotes or either double quotes. Okay. So here you can see I've used single quotes, or else I'll be using double quotes. See, in first sentence, I have used single quotes, and second, I've used double quotes. You can use either of this. Okay. When it's a string alphabet characters, you have to use single quotes or double quotes. For numerical values and decimal values, you no need to use anything. You can just directly put it. Okay. So if I want to print this, I'm a string. What I'll do is I write print. Inside this, I'll write the variable name. Okay. So when I click run, syntax error. This should be equal to run. See, here in the output I'm getting I'm a string. Here I have three variables with me. This my variable 42, my var I'm a string, and this other variable I'm also a string. Here I'm having three variable, but here I'm just printing what is my VAR. So whatever the value of my VAR is, I'm getting it. Okay. So if I'm giving it as my name, so if I want to greet the user, say I want to say hello Bala or hi Bala, what I'll do is hello underscore. See here in name, I've stored my name. If I want to greet, whatever, see this is a value, okay. Whatever is after comma is a value. If I want to print some message, like the sum of this number is or hello world, hello user, what if I want to print a message, inside print I'll use double quotes and I'll write the message inside it. So whatever is there inside the double quote, it will be printed as it is, okay. Then I'm giving a comma to separate it, then I'm writing this variable. So here I'm getting printed hello Bala. So if I want it in a single line, what I'll do is instead of this comma, I'll add it. This is concatenation of strings. Okay. See now this both are in single same line. Okay. Hello Bala. Got this? Any doubts in this? No. Okay. So if you guys are parallelly practicing, then let me know. I'll just go a bit slow, or else I'll continue. Okay. See here inside my name, I've stored Bala, right? So what I can do is I can just put a note here, double quotes, and I'll write what my name contains is username. Here we are just using one variable and printing it, right? So whenever you are solving real world problems, you may be having 50 to 60 variables. You can't remember each and every variable. So whenever you are declaring it or writing some function, you want to take a note instead of writing it on a paper separately, you can just write it next to it in the code. So what this compiler does is whenever it executes the code, it will just skip this part. Wherever it sees a double comment, double slash, whatever next to it, it will skip the part. It won't be executing those lines. That is just for human understanding. Okay. If you are giving a uh, if you are giving a comment in single line, you can use double quotes either after the sentence or you can put it in next line. Okay. If it's a multiple line comment, what you can do is slash star and to end it star slash. Okay. So whatever inside this uh, thing is, everything is a comment. So if I come out, this is not a comment. Okay. Got it? Any queries in this? No, right? So after a function, there should be parenthesis. Okay, this is parenthesis, and inside this, I'm passing a variable. See, this is a function. If anything has a parenthesis after it, it is a function. If I go to docs, I'm going to classifier. So in classifier, I'm taking decision tree. Okay. So if I'm clicking on it, see here tree string, then here's a parenthesis. Okay, inside this parenthesis, I'll pass my image. Whatever the image I want to do the classification, I'll pass the image or whatever the argument is needed. Here the type is string. So I'll pass string format. So if you see some other geometry, see here I'm passing coordinates and projection for this particular function. Similarly, you can just read it what the function does and what parameter it does. So print's function is to display the message, to print the message in the console. So whatever value I give here, prints it. Okay. This is for message and this is to print any value. Okay, it's getting printed. So if I go for slope and slope, what the slope does is it will find the slope. So whatever image value I pass, if suppose I have L8 in my this thing, wait. Landsat 8. Okay, I'll import this. I'll rename this. So this is my variable. So if I want to find slope, I'll give slope and inside I'll give an image L8. But L8 doesn't have dem collection, so I have to go for SRTM. Okay, I'll find SRTM data and I'll pass SRTM data inside it. So here slope, SRTM. That's it. Then I have to print this in my map. Got it? Any doubts, anyone? No, right? Till now, you understood what function is and how to pass parameters or arguments, right? Okay. So next data type is list. Okay. As of now, I was storing just a single value, whether it's a username or average or numerical value, whatever it is. I was storing a single value. Suppose I have marks of 10 students or I have 10 coordinates of 10 addresses. What I'll do, I'll create a list and put everything inside the list. Okay, instead of creating 10 different variables, I'll create a list and inside list I'll put everything. Okay, this is say address 1 or let's say pin codes 600,025 600,093 400,095. So if you give a string, a single quote or double quote, it's a string. Okay. So these are treated as characters or alphabets. It's not treated as numerical numbers. Okay. So if you want to or integer value, then you don't need to give any of the string. Got it? Any doubts in this? No, right? Run. See, nothing is printed. Here I have a list, but nothing is printed. Can anyone tell me why there's nothing in my console? Guys, you can unmute yourself and speak if you're comfortable. You have declared my list, but there's nothing in the console. But in the code, I'm having a list, but nothing in the output. Why? Anyone? Okay, so here what I've done is I've just declared it. Okay, I haven't printed anything. So there's nothing printed in my console. Okay, if I go for print, so from this list, I'll be just printing a particular value. Okay, whether apple, color, or wheat. Wait a second. No, it's not about semicolon, right? I haven't given print, so nothing is printed over there. Semicolon is already there. Okay, so if I print this list and you see, you'll get the whole list over here. Wait, I'll just make the screen small so reset. See, apple, color, wheat, whatever there's in the list, everything is printed over here. Got it? So if I want to print something specific, if I just want to print apple, what I'll do is I'll give the index number. The indexing start here from 0. Okay. And suppose I'm having 4 elements in my list, the indexing ends at n minus 1. That is 4 minus 1, 3. So this is my 0th element, first element, second element, third element. Okay. So here inside list, I'll write 0. So if I write 0 and run, see only apple is getting printed, right? If I give 1, color. If I give 4, undefined. Because here I'm having 3 elements. The number starts from 0 and ends at n minus 1. Okay. If I give 3, run, 43. Any doubts in this? This is the very basics of any programming language. Okay. If you go for any other programming language like C++, then instead of print, you will be using C in, C out. C in to take input and C out to display it. Okay. The keywords changes, the function name changes, but the core principles remains the same. Okay. And if you go to Python, there is no need to put semicolon. Okay. No questions till here, right? So we can jump into some GIS operations on Google Earth Engine. Okay, so I've searched for SRTM. I'll import some images now. Okay, I'm importing SRTM data. That is my elevation 30-meter resolution data. I'll rename this as SRTM. Okay. Now what I'll do is I want to print it. So if I write print, inside print I'll write SRTM and semicolon, run. See, it's not printing and displaying anything me on the map. Okay. Here in the console, it's getting printed. Like whatever the details are, it's getting printed over here. Okay. So, but I don't want this. I want it in my map. So print is just to print in the console. It will print the text values. I don't need this. I have I've commented it. So what I'll do is, so similarly to print, there's a function called map dot add layer. So inside my map, I don't have any layer now. So if I write map dot add layer, what it will do is it will add the SRTM layer over my map. Okay. The map dot add layer SRTM, same. It's a function. So there's a parenthesis. So inside this parenthesis, I'll pass what what I have to print or display. I'll pass it inside this. That is my argument or parameter, and I'll run. See, now I've got a layers column. So in layers, there's something displaying over my map, right? I'll zoom out. Here you can see a gray image above my ground, right? So if I go to inspector and I click somewhere here near Mumbai, so wherever I've clicked, the elevation is 487. So if I click somewhere in Himalayas, see, this is 5,459 meters. This is in meters, and this is the meters from the mean sea level. Okay. Any doubts in this? See here, wherever I've clicked now, it's 268 meters from the mean sea level. See, it is giving the points, 70 lat long values, and here's the elevation value. Any questions, doubts? So, but this is a grayscale image, right? So suppose if I want to visualize, what will I do? Here I'll add some more parameters. Wait, first I'll comment this out. If I don't know map.add layer, I'm not remembering it, what the exact thing is. What I'll do, I'll press control space. Then I can see whatever the function is present here. Okay. Map.add layer. If I go over map.add layer, see here what all arguments I can pass. Everything is defined there. See, first thing is I want to pass an image. If I'm passing the image, then only I can visualize it. First thing is I need an image, right? So, okay, then I'm pressing control space. See, first thing is an image. Then the visual parameters, like what should be the minimum and maximum values, and what should be the color to it, everything. Okay. Then what should be the name of the layer, and how it should be shown, and the opacity of the layer. Everything I can customize over here itself. Okay. So here I'll pass SRTM. Then in visual parameters, I'll give a range for the elevation. Okay. Minimum :0 underscore maximum :3000. So it will visualize from 0 to 3000. If suppose the elevation goes beyond 3000 also, the color will be saturated at white. Whatever color 3000 has, same color will be applied to 3000 plus elevation. And if it's below 0 meters, then also whatever color is there for 0 meters, the same thing will be continued below also. Okay. So next thing is name. I'll give it as SRTM. So name is a string. Okay, so I'm giving this single quote or double quote, whichever is suitable for you, semicolon. I'll run this. See, now it's visualized in black and white. You can see that, right? Any queries in this? So whichever elevation is low, I'll be getting a dark black color. See here the elevation is 0 where it's dark black. Actually it's C. See here it's dark black. It's 0. If I go to the white region, here you can see it's 4998, 5000. If I go to the gray region, it's 1000. Got it? Any queries in this? Suppose you don't want this black and white, you need some other colors. Yeah, I'm coming. I'll show water examples also. Wait a second, I'm coming over there. Wait, suppose you, okay, I'll show this color example there itself for water. Okay. So as of now, I've added DEM data and I've shown it. Now we will see water occurrence. Okay. Water occurrence. Anyone, what data set I should be using? Wait, I'll search for JRC. See, here I'm having global surface water mapping. Okay, JRC global surface water mapping. I'll import this. I'll name it as water. Okay. So similarly, instead of SRTM, now I'll do for water. Okay. So I'm copying and pasting the same code, and I'm changing this SRTM to water. Okay, I've changed the name. So in visual parameters, in first case, the data was in meters. Okay, 0 meters to 3000 meters. Okay, here I don't know, and here actually the values is in percentage. Okay, water level is in percentage. I'll show you the console. Okay, I'll show you the console. I'll print this. Let's see what happens. I've just copy pasted, and instead of SRTM, I'm giving water. Let's run this and see what happens. Water is getting printed again. Water shouldn't be getting printed again. Okay, I'll change the color and visual parameters, everything for water surface weight. So it's easy for you to understand. Okay, so see, in digital elevation, we just had one band. Okay, so it was easy for, we no need to give any band or filter out any band. So here we just had one band. So in water we are having 7 bands. From the 7 bands, we have to find which band is for occurrence. Okay, so here if I click on inspector somewhere, see, this is for water. Water in band list, you can see 7 bands. If I open this, there's occurrence band. Occurrence band. Okay, if I extend this, here you can see all the values regarding it. Okay. So what will I do is, here water and visual parameters, I'll visualize just the occurrence band. Okay. Here in bands, I'm audible, right, guys? I'll give occurrence. Bands occurrence. Minimum 25% of water. See here, it's a numerical value, so I no need to give string. Minimum 25, maximum 80 percentage. Okay. Now here I'll give a color palette. Okay. Instead of black and white, I'll give a color over here, light blue to dark blue. Okay. So I'll give palette. Inside palette, I'll give my colors, light blue / blue, and at the end water, right? Okay. So if I run this, I'll turn off my SRTM. I just visualize the water layer. So you can see my water layer, right? See, if I click somewhere here where there is a light blue shade, see here the occurrence is 49%. Wherever there's a light blue shade, if I click over there, see here it's 45%. If I click on dark blue, you can see here it's almost 100%, right? I'll show SRTM also. Any queries in visualization? No, right? We can move forward. Good to go. See, we have done nothing. We have just taken the data from the Google Cloud and we are visualizing it till now. And we have given some visual parameters. Nothing else. Any doubts in this? Initially, you can find like, array, how I'll remember so many things, but you don't have to remember anything. Just the basic principle, like the syntax should be correct. And if you want this map.add layer, you'll be using regularly. Okay. Then once you get into it, there are just 2-3 factors which you need to remember. If you practice regularly, you'll get a hang of it. No need to mug up anything or by heart anything. Like if you are using it on a regular basis, you'll get a hang of it. No need to remember anything. And apart from this, all the algorithms which you will build is totally based on your ecological or marine survey, whatever you are doing. Only that calculations you will be doing here later on. Okay. So nothing much. Okay. You have to learn, mug up anything, nothing like that. This map.add layer, print, export function, everything you will be like 4-5 functions you will be using common on regularly in every program that you will be getting used to it with no time if you are practicing it regularly. Can we move forward, guys? Everyone. So this water layer, I'll just comment it out. Next, we will use some functions from this document and do some calculations. Not calculations. We will use readily available functions. Okay, to do some analysis. As of now, elevation data was there. We have visualized it. Okay. Now what we'll do, we'll search for slope here and we'll use it. Slope equal terrain slope. If I go here, see here, I just have to pass an image. Okay. In map.add layer, what we are doing is we are passing an image and visual parameters and its name, everything. Okay. So for slope, I'll use this EE terrain and I'll pass. Wait, I'll just copy paste this. I'll copy this. If I want to find slope, I'll copy this. This is a function, right? So whatever value comes, I have to store it in a variable, right? So I'll declare a variable slope. I'll write this function here. Instead of input, I have to give the input image, right? So here I'll write SRTM. SRTM is my input image. I'll give a semicolon. Okay. So now whatever slope value is calculated, everything will be stored in slope, right? I'll comment out this also. Now I'll visualize this. Map control space. See what all function is there. Add layer. Add layer inside here. I'll give slope. First the name of the image, then visual parameters. Minimum value 0, maximum angle 45. I'll name this layer as slope. Okay. So slope is a character, so I'll put single quote or double quote, semicolon. Okay. I run this. See here, there is no much of slope. Here, if you see in here, there's not much of slope. If I click somewhere, you can see 0.01. If I click on the white, see 19 degrees. Zoom in a bit. 37 degrees. Any doubts in this, guys? Anyone, any questions, queries to ask? So now we'll go to some statistical functions. Okay. So now I'll just turn off this layer. Guys, I'm audible, right? Everyone?
Yes, sir, you are.
Yeah. Okay. So I'll go to some place. I'll find half region I'll take for water, half I'll take terrain, and we'll do one slope analysis, and we will find the water occurrence level for a particular area. Okay. So here you can switch between map and satellite images also. Okay. So here what we can do is, see here, yesterday I've taught you the data types, right? Point lines and polygons. Here, if you want to create some point lines and polygons, you can come over here in the left hand side top of your map. Either you can take rectangle or this polygon. If you have a irregular shape, take this polygon for your study area, or else you can just take a rectangle. See, when I click on the rectangle, new layer is formed. Okay. Now I'll just select my area, study area. Okay. Now I've selected my study area. Whatever code I write will be executed for this area only. Where from all this document parameters will get, are they built in? Yes, this documentation, everything is in docs. Once you create an account, inside this docs, you can see all the functions. If I search for slope, I am getting slope. If I search for hillshade, see hillshade functions. Every GIS functions is built in over here. If not, you have to write a custom code. If I find for image classification, if I type image classification, see what all classifiers are there, everything is there, chart, UI, everything you want to create, you can do it from here. You just need to know, you need to have a basic understanding of coding and how you can take this function and feed your data and visualize. Only that much coding knowledge you need. You don't have to solve any world problem or something. You just need to know how to use this function, take this function, feed your data and get the output. That's it. Okay, so now I've chosen my study area or region of interest, whatever you call. So here, when I created this, here you can see one variable is created, geometry, polygon, 4 type. See, this is a polygon. Yesterday I taught you, right? Points, lines, polygons. So this is a polygon. I'll rename it as region of interest. Okay, region of interest. Now I'll come down. See, this is statistics. Okay, but do I need this? No. So I'll take this out. I'll take this up. Come on. If you want me to zoom in little bit, let me know. Okay, if the texts are not clear or you're not getting what I'm teaching, just stop me over there. Okay. So now let's calculate a statistics of using this. I'll I'll calculate the average slope of this area. Whatever my study area is there, I'll calculate the average slope. Okay. So here a little bit of statistics will come into play. Just listen carefully, guys. Okay. Wait, I'll comment it off. Statistics of area. This is just for my understanding. Okay. Now here I'll take variable slope d. Here on top of slope, slope is my variable over here, right? I've used the SRTM data to calculate slope and I've saved it in a variable slope. Okay. Now I'm using the same variable. On top of it, I'm using reduce region function. So now the slope is for each pixels, right? Whatever pixel is there, for each pixel, the slope is there, right? So now I want it specifically just for my study area, and inside my study area, whatever is there, just average it and give me a single value. Okay. So here I'll reduce it to one single value, right? So I use reduce region function. If you don't know, in between you can write control space. Yes, reduce region. It will pop up. Okay. If you don't remember everything, control space, reduce region. Yeah. reduce region, and inside this, I'll give all the parameters which are needed. Enter. First parameter is reducer. What kind of reducer I have to use? I'll use reduce. I want to find the sum of all the slopes, right? No, I want to get the average. So it average is mean. So if I don't know exact name, I'll just press control space and I'll find what all things are there. Okay, count and non-zero bitwise first. It's mean. See here, mean is there. So I'll click on mean. So inside, yeah, mean. Next, I want to find of mean. Next is for which place. That is my geometry. Geometry क्या नाम दिया था? ROI, right? So here I'll give ROI. So for ROI geometry, find me the mean of slopes. Okay. Now the scale, this is a default value 30. So if you are using some different images, your own images, at the time the scale is the scale accordingly. Okay. Semicolon. See, this whole thing is a single line. Okay. If I have kept it in single line, then it would be difficult for you. You have to read it like this. You have to scroll and read it like this. As of this map.add layer for water bodies, you can see this line, right? I can't read the full line in a go. I have to scroll this, right? So instead of that, what you can do is you can break down the lines. See, after this colon, I've given it in a single line. Here I don't have to give semicolon. I'll just give comma. Okay. So this is a single line and this line ends over here. So here I've given a semicolon. Wherever the line ends, I have to give semicolon there. Okay. So I break down the single line into 3 components so it's easier to read. Okay. Now what will I do? I'll print this. Print average slope. Here what value I have to print? I'll print the variable name. So whatever calculation is happening, everything is stored inside this variable, right? So I'll run this. See in the console, you can see average slope. See for this area, the average slope is 1.0 degrees. Got it? So now I'll find total water occurrence. Okay. Next variable, I'll take variable water. D is just for dictionary, guys. Okay. Dictionary. Okay. Water dot select. See, water has 7 bands in it. So I just have to select the particular band which has the occurrence. Okay. So here, this is just the occurrence band name. Okay. Even if the spelling is wrong, it will throw an error. Dot get. Select the pixels which are having values more than 90. Okay. Get greater than 90. Okay. Dot multiply. See, if I want to find the total water quantity in this grid, what I have to do, I have to select the occurrence band, right? So I'll select the pixels which are having value greater than 90. Okay. I'm doing just for greater than 90. So each pixel, so if I have one pixel is of 30 meter by 30 meter resolution. And for that, I'll be just getting a value 90. But the 90 is not correct value, right? I have to multiply it with the area. So the 90 percentage is for the 30 meter by 30 meter area. So here that's why I'm multiplying it with the pixel area. This thing, whatever I'm writing has nothing to do with coding. This is just statistics and basic mathematics and your understanding. Okay. This is not any formula. This dot is for multiplication. Okay. So I'm in water, I'm selecting a band. I'm inside the band, I'm selecting whatever is greater than 90, and from the 90, I'm whatever the pixel area is, I'm multiplying it with it. Okay. So this is a function pixel area. So I have to give double quotes, right? So now I'll come to reduce region. After this, I'll come down. Yes. Dot reduce region. Okay, I'll just type it out. Reduce region. Okay, this is so what reducer I have to use? Similarly as above, reducer. In last case, I have used mean. Okay, I want to bring it down to a single value, average. I was finding the average, right? So here I'm finding the total volume, the water. So here I'll be using sum, right? Any questions in this? Sum. Now next the same thing, geometry and scale. I'll copy this. I'll paste it over here. Scale. Okay. I'll end this and I'll print it. What are the okay? I'll run this. What are the okay? This W is capital. Okay. Run. See water dictionary. Here, this is the total water in meter cube for the selected area. Okay. These are some statistical operations which we have done, and this is how we. So suppose we do this. This I've done for a particular pixel. Okay. Here I'm doing for a particular pixel. If you are doing for the whole area, then you will be getting the output as we seen for slope. Okay, this we are doing for each pixel. We are giving the elevation and we are finding the slope for each pixel. So we are printing it as a map. Now this value is reduced to one value. Okay, one value. So we are getting the value and printing it in the console. Sorry guys, I have to go a bit fast for to cover this thing up in short constraint of time. So everything is clear, right? If you guys have any questions, you can ask now. Guys, any queries? I hope the session was helpful for everyone. So guys, because of time constraints, I can't cover much here. So I tried to cover how much is possible. So we are having a full course of it. Like we'll be doing all the terrestrial and marine applications in Google Earth Engine. Okay. So it's a 3-month course. I'll be teaching everything in depth from fundamentals, everything. Each and every line of code I'll go slowly and teach you guys. There will be doing some land use classification uh, and everything. Okay. So it's wait, I'll show you some of the applications. Okay. Wait a second. I'll this oh I'm in documents tab. Okay, so these are the we'll be building around 15 applications. This is for yeah, water balance and drought. Wait a second. Okay, done. See here we have classified it according to this many factors: cropland, rice, mixed forest, everything we have classified. And so similarly, heat islands, I'll just make this short. Okay. Okay, the memory limit for me has exceeded right now. Wait, oh, it's coming. See, urban pixel, non-urban, all the environmental classification we'll be doing here. Okay, related to health applications, gold mine digging, all the terrestrial activities, like your what you say, land use, land cover mapping, finding the difference, how much built up index has grown from within the 10 years, air pollution monitoring, water level monitoring, the water pollutant contents, everything from terrestrial to marine. We will be creating 15 full-fledged applications. Okay, so what we have covered in this 2-day course is just the basic fundamental. Before creating any full-fledged application, I have to give you the core basement, right? Core base thing. So yesterday I've covered the fundamentals. Today we have created few statistical calculations we have done. So for agricultural environment, yes, run this. Okay, so once it's done, you can export it as well. Okay. So if you guys have any queries, you can just connect anytime with me or the team. So the total course fee for terrestrial and marine application is around 14,000. If you join in a group of 4 to 6, if you join in a group of 6, then the fees is reduced to 9,000. Okay, a group discount is there, and the other offers also you can check with the team regarding it. Okay, so if you guys have any queries, you can just ask me, whether it's regarding your GIS or Google Earth Engine, whatever it is, you can ask me.
Dear participants, the link for our upcoming remote sensing and GIS workshop has been shared in the chat box. If you have any doubts regarding the subject matter taught in the workshop, I encourage you to ask Sir directly for clarifications.
The classes will be online itself. It's a 3 months course. So even if the course isn't completed 3 months or you're not getting it, will go slow. I'll take a different session for you guys. Whoever is lagging behind, you can't keep up with it, then we'll have a different session, doubt session, everything with that. And I'll be sharing all the codes too, like whatever we are developing, all the codes, repository, notes, everything I'll be sharing in the course. And I guess someone had a doubt regarding 3D yesterday. I told we can connect offline. Wait, I want to mark mangrove location in India. Mangrove locations, you can search first. Don't restrict yourself to Google Earth Engine or QGIS or any software. Okay, first go with the data. First search for what all data is available with you. Okay, first go with the data sets. You try to find what all data is available. Try to import those data, and you see what all factors you can calculate with it. So for mangrove locations, you have to do a land use land cover classification for it to find the specific mangrove, as I shown you in the this thing. in the application we have classified as crop plant, rice, everything. So similarly, you have to classify mangrove and extract the features from the satellite image. Mangrove feature differently from satellite image. You can do this in Google Earth Engine or any other software. The principle remains the same, but here half of the steps are automated in Google Earth Engine. That's LULC maps you have to prepare, right? LULC, it's available. Like if I'm creating a LULC map, then I'll be publishing it in a paper or somewhere. So you can get it from there, but it won't be available for ready use. For ready use, if you want to use it for your project, you have to prepare those LULC maps. You can't get it readily available. Yesterday, someone asked about 3D mapping or something. So if you can repeat the question, I can clear it here itself. I told we can connect offline after some time, but yeah, we didn't. So if anyone has any question relating 3D, anything, you can ask. Exact data required for LULC maps is your either you can go with Landsat 8, Landsat 8 or 9 or Sentinel 2 data. What happens in this data type is like, wait a second, I'll show you. Downloads the Landsat 9 image. See here in Landsat 9, 10 or Sentinel data, here each data is stored in bands, band 1, band 2, band 3, band 11, and so on. So what happens in LULC map is we create a composite of it. Suppose for vegetation, I'll create a composite of 4, 5, 6, whatever the combination is. Instead of RGB, we will be taking 3 bands and we'll be creating composites. It will show us true color composite, false color composite. Suppose we are creating a false color composite. So from that, all the vegetation will be highlighted in red color. We will be taking training samples. Some of the data we will be taking as samples for each classes, whether it's a mangrove, or whatever, wetland, built up area, barren land, whatever it is, we'll be taking samples from it. And then we will train the data, and whatever area we need to do the classification, we'll run the classification. And yes, we'll be getting the output LULC map for the whole area. This is the basic flow. Okay. The process is like I'll cover LULC2 in the whole course. But yeah, this is the basic outline. You can search for, if no one. Yeah, any other doubts? Like from the registration form, I got some queries. Some ask how to create a successful career in GIS. Okay. So GIS is just a tool, guys. GIS can be used in various sectors like urban planning. You can blend GIS with other technologies, IoT platforms. Like suppose I'm having some data, environmental factors, not environmental factors. Let's say I'm having all the electrical assets map for my area, for my whole country. I have electric cables, transformers, everything. So if I've mapped everything and I've connected IoT devices to it, so from IoT I can get the live data and I can monitor everything from my place itself. Like suppose if any transformer is going to go down, I'll be getting a notification before itself. So I can change the line route of my electricity so that it's undisrupted for the end user. Okay. So if I'm doing urban planning, I can try to bring the, instead of stopping it with 3D, I can go for virtual reality, augmented reality, mixed reality. I can blend those things inside GIS and I can do various stuff. As of now, not much people has worked on GIS. Mostly people are sticking with just LULC thing. So if you see some random master's thesis for anyone, they do carbon acquisition, LULC, land use, land cover changes, shoreline changes, how the shoreline is being changes for over 10-15 years, all those things, and that too using traditional data itself. Now not much people are aware of Google Earth Engine too. So if you have completed your masters or your masters ongoing, if you know Google Earth Engine and Python very well, you are like you have been practicing it for 6 months or 1 year, so you can easily get a PhD in European countries easily. Like in European countries, the PhD is like it's a kind of work only. You will be working at in some research institute, and you will be getting paid a good stipend for it also as well. Getting PhD, like there is not much people in this GIS domain. So, but the same time, if you go to any corporate jobs here in India for in GIS, it's like you will be just doing the digitization stuff. You will be creating. I showed you the water data yesterday, right? Similarly, you will be drawing all this data, creating this data. So if you stick till the creation of data, then it's a bit difficult for you to come back. For 1 year, 1.5 year, GIS analyst, GIS digitization is okay, but don't stick with that. Like you have to see, if you are going with any corporate world in India, then it's the career is becomes more stagnant. Okay, if you're going with a developer role or something, then yeah, you have a good growth. The package is good, everything is good after 3-4 years. In beginning, it's very difficult to get a job in GIS. I'm talking in India. Okay, if you have some plan going abroad, you don't have to support your family much, then you can try it. If you have any questions regarding it, regarding PhD or anything, you can just bring me anytime. And how you can use this for ecology and forestry. So forestry, there is forest departments. Either you can do freelance work from them. I have some few. I do some freelance as well. Okay, so I have some clients who work in wildlife. What they do is they go to forest, collect the data regarding the species which um, they are working on, the XYZ species. What happens in forest is don't get any network or something. Nothing is there, so they can't use the phone or anything. So till 1 year they were working, and they were getting the data, but they don't have a exact idea where they are getting, what data they are getting. So they called me once. Then I went there. They had the data and the GPS tracker, Trimble or whatever GPS tracker they are having, they just capture the lat long there. So what I did is I plotted everything. So for them in the map, I categorized everything and plotted everything, cleaned the data, and did everything. Then they came to know, okay, so this is the only area where we have concentrated so far. This many places are remaining. We have to go here too. Till 1 year, they were no idea. Like inside forest, they don't get any signals, mobile signals. They can't use any Google Maps or anything, right? So once they come, I plot the data, I do the analysis, I give it to them, like what all the species, how many variants they have, find everything. So either you can do it as a freelance or join as a GIS analyst in any forest department or any NGOs working there. So yeah, in forest departments too, they have GIS analysts over there. So you can do forest fire monitoring, everything, like what all environmental factors are there. It's nowadays it's become very easier to calculate. Okay, so you can do it. You can send a proposal to government like saying this thing is possible, and yes, it's but easy to get sanction for this projects also. I'm not saying 100% you will get a good career in this, but yeah, you have to do some hard work, and luck also plays an important factor in it. So this is what major questions I've got, like what is the application in ecology, how to build a successful career in GIS. I'm from economics background, ecological background. So it is, yes, these are the major questions I've got. So if you have some other questions, just let me know, guys. Or else we can wind up here. Guys, any queries? Use of GIS in agriculture. Okay, for agriculture, like we do precise farming, and like instead of this 30-meter resolution, we can just fly the drone data, and we can get the data and do all the analysis. Like actually, there are two type of satellite data: hyperspectral data and this thing. So using hyperspectral data, what we can do is we can even find the crop health also, crop health, and all the soil. What is the capacity of soil to hold the water, everything. So before going to any soil sample test in the lab, you can do it prerequisitely using GIS and remote sensing. Then later on, you can go. Then you'll get an idea whether you have to do the soil sample. It will be useful or not. So if there's no sense, then you no need to go to the lab and spend 50 to 60,000, right? So you can do the preliminary test here itself before. Then you can go for any soil test or any other kind of.
I guess we can conclude the session if none of the participants are having any questions. Will that be okay?
Yeah, yeah.
Okay. Dhananjay, go ahead and conclude the session.
Yes, ma'am. As we conclude our two-day workshop, I would like to extend my gratitude to all the participants. A very special thanks to Bala S. Subramaniyam for his valuable insight, which have contributed to the success of this workshop. Specially announcement, we are thrilled to represent an irresistible offer, the original price for the full package of our upcoming remote sensing and GIS workshop is 18,000. However, by gathering a group of six, we will available to you at rupees 9,000 per head. Just a reminder, the registration link for our upcoming GIS workshop is conveniently pinned on the WhatsApp group. Do take advantage of early bird discount and installment features. Additionally, I kindly request all of you to fill out the feedback form. Your feedback will help us improve our future event. Thank you all once again for joining this workshop and making it a memorable one.